Welcome to our channel Electron Chemistry Tutorial. I am Vijayalaxmi. So now I am going to teach you objective bits from Chemical Kinetics for JEE Mains, NEET and MSET. So stay with me till the end. Okay, let's start. So before going to the bits, so let's recollect some important points from Chemical Kinetics and important formulas also. Clear? Then first of all, what is chemical kinetics? So it is a branch of chemistry that deals with the study of reaction rates and its mechanism. So reaction rates nothing but speed of the reaction. So now how to define speed of the reaction? Speed of the reaction small r is nothing but change in molar concentration of reactants or products per unit time. Clear? So simply here, suppose for example reactant gives products, then how to write rate or speed of the reaction? R is equals to delta concentration of reactants by delta T, that is equals to plus delta P by delta T. So this negative sign indicates the decrease in the concentration of reactant, positive sign indicates the increase in the concentration of products. Clear? So simply as reaction going on, so reactant concentration decreases, so products concentration increases. Clear? So then simply how to draw the graphs for the reactants? So this is reactant graph. So reactants concentration gradually decreases. So here concentration of reactants time. So then here concentration of products per time. So products concentration gradually increases. Clear? Now suppose for example A plus 2B gives rise to 3C, any chemical reaction. How to write rate expression? Rate expression simply here R is equals to minus delta A by delta T, that is equals to minus half any stoichiometric coefficients are present in the chemical reaction, so they are taken in the denominator, right? Now delta T. Next plus indicates the increase in the concentration of products, 1 by 3 delta C by delta T. Clear? So this is what simply rate expression. Simply rate of disappearance of A, rate of disappearance of B, rate of appearance of C. So decrease in the concentration of A, decrease in the concentration of B, or formation of increase in the concentration of what? C. Clear? So the next go for what? Factors affecting on rate of reaction. Factors affecting on a rate of a reaction. So many factors we learnt. 4 factors. Nature of reactants. So next concentration of reactants. Okay. So then next third one, temperature. Fourth one, catalyst. Okay. Ionic reactions are very fast when compared with covalent reactions. So next, concentration of reactant. So simply rate of the reaction directly proportional to concentration of the reactants. As concentration of reactants increases, speed also increases at given temperature. Clear? Next, temperature effect. As temperature increases, simply rate of the reaction also increases. Clear? So simply here, so this is a rate for every 10 degrees rise in temperature. So reaction rate may be doubled or tripled. So that is nothing but simply temperature coefficient. Okay. Temperature coefficient, that is nothing but ratio of two rate constant differ by, suppose for example 35 degrees Celsius, 25 degrees Celsius, that may be values are doubled or tripled. For 25 degrees Celsius to 35 degrees Celsius, rate may be doubled or tripled. Simply for every 10 degrees rise in temperature, the reaction rate may be increased by 2 times or 3 times. Okay. Next, effect of temperature is explained by Arrhenius equation. Arrhenius. That is what? K, rate constant, is equals to A e to the power Ea by minus Ea by RT. So by applying logarithm, we'll get log to the base 10 of K is equals to log to the base 10 of A minus Ea by 2.303 R 1 by T. So these formulas are very important for objective bits. Okay. So these formulas also. Okay. See here. So for different temperatures, means T1, T2, we'll get different K values, means K1 and K2. So for that relation, we'll get log K2 by K1 is equals to Ea by, suppose you can assume it as a coefficient factor, Arrhenius factor, so is constant, Ea by 2.303 R 1 by T1 minus 1 by T2. Okay. So these are for different temperatures, we'll get different K values, that is the relation between them. So these formulas are very important. Okay. So next, simply catalyst can, positive catalyst can increase the rate of the reaction, negative catalyst can decrease the rate of the reaction. So all these points keep in your mind. Okay. So let's do some objective bits on these formulas. First problem. The reaction X gives rise to Y. The initial concentration of X is 2.5 moles per liter and its concentration after 3 hours 0.7 moles per liter. What is the average rate of the reaction? What is the formula for average rate of the reaction? Simply rate average is nothing but R2 minus R1 reactants T2 minus T1. So R2 nothing but simply reactant here X final concentration minus X initial concentration T2 minus T1. This negative sign indicates the decrease in the concentration. Clear? So what is the final concentration after 3 hours? What is the concentration here? 0.7 minus initial concentration, how much is given as 2.5 by time is given as 3 hours. Okay. So simplify. So simply here minus of minus 1.83. So minus of minus nothing but plus. So this is how much? 0.6 moles per liter per hours. Okay. Also you can written as 6 into 10 power minus 1 moles per liter per hours. Clear? Clear everybody? This question also given as with graph. So I will show you. Suppose for the reaction X gives rise to Y, find out average rate of the reaction. So with the help of the following graph. Okay. Concentration of X time. Okay. So here initial concentration given as 2.5. Next final concentration 0.7. So initial time 0, final time 3 hours. Okay. So by this we can find out what? Rate average. So nothing but so this is what? X1, X2. So this is maybe initial concentration Xi or X1 final concentration. Okay. So minus of final concentration of X minus initial concentration of I by change in time. Delta T is how much? 3 hours. 0 to 3 hours simply. So simply here concentration minus of 0.7 minus 2.5 by 3 hours. We'll get minus of minus 1.8 by 3, that is nothing but 0.6. Clear? So maybe they will give question like this, or simply for reaction X gives rise to Y, find out average rate of the reaction. So with the help of the graph. Okay. So in that graph they will give initial concentration, final concentration, initial time, final time. So by using this graph we can identify which is initial, which is final. So which is the time. So we can calculate the simply average rate of the reaction. Clear now? Very good. Next problem. See here. For the reaction to A plus B gives rise to C, the rate of formation of C is 0.25 moles per liters per hour. So what is the rate of disappearance of A and B? A and B. First of all, so write a rate expression for above reaction. So rate expression, rate R is equals to minus of 1 by 2 delta A by delta T, that is equals to minus delta B by delta T, that is equals to plus delta C by delta T. Clear? See here, this is what rate of formation of C. So this rate of disappearance of B, rate of disappearance of A. Okay. So now rate of, what I am saying here, rate of appearance of C is how much? 0.25 moles per liter per hour. Rate of disappearance of A, nothing but see here, delta A by T. So that is equals to C, nothing but delta C by delta T. So this 1 by 2 here minus 1 by 2, this denominator goes to here. So simply delta A by delta T, that is equals to 2 into delta C by delta T. So rate of formation of C how much? 0.25. 0.25 is given as C here. How much? 0.50 moles per liter per hour. So this is what rate of disappearance of A. Okay. Now next, rate of disappearance of B. Rate of disappearance of B. So that is exactly equals to the rate of appearance of C, no? So that's why simply here, what is this value? 0.25 moles per liter per hour. So simply rate of disappearance of A 0.5, rate of disappearance of B 0.25 moles per liter per hour. So that is the answer only. See how simple. Okay. Next go for third problem. See here. For the reaction A gives rise to B. So it was found that the concentration of B increased by 3 moles per liter in 2 hours. In 2 hours. So what is the average rate of the reaction? So that is similar to the first problem. You can do it. Okay ma? So simply in first problem you can find out the what average rate of the reaction for reactants. But here products. Simply here, increase in the concentration, nothing but how much increases? So change in concentration of products, that is B, by time. So how much increases? Then what is the time? That's all only. Okay, you can do it and answer write down in the comment. Okay, next. Fourth problem. The rate constant of first order reaction at 37 degrees Celsius is 2 into 10 power minus 3 per minute. The temperature coefficient of this reaction is 3. So what is the rate constant at 27 degrees Celsius? Simply what is that? Temperature coefficient formula. So ratio of two rate constant differ by what? 10 degrees Celsius means 37 degrees Celsius, 27 degrees Celsius. 37 degrees Celsius, 27 degrees Celsius. So is that temperature coefficient value is how much? Tripled 3. Okay. So simply, so what is the rate constant K at 37 degrees Celsius? 2 into, that implies 2 into 10 power minus 3 by K 27 degrees Celsius is equals to 3. So these places are exchangeable for calculation. We will get what? K 27 degrees Celsius is equals to 2 into 10 power minus 3 by 3. 3 ones are 3, 6 are 6 are. Simply 6.6 into 10 power minus 4 what? Per minute at 27 degrees Celsius. Clear? It's very simple. See here, fifth problem. The rate of a reaction becomes 2 times for every 10 degrees rise in temperature. How many times the rate of reaction will increases when the temperature increased from 10 degrees Celsius to 50 degrees Celsius? What is it? Simply, for every 10 degrees rise in temperature, suppose for example here 10 to 50, no? 10 degrees Celsius to 20 degrees Celsius, then 30 degrees Celsius, 40 degrees Celsius and 50 degrees Celsius. Okay. For every 10 degrees rise in temperature, the reaction rate becomes 2 times. Here for 10 degrees to 20 degrees reaction will become 2 times. 20 to 30 also will become 2 times. 30 to 40 also will become what? 2 times. Then 2 times. How many times? 1, 2, 3, 4. So 2 power 4. How many times? 2 2s are 4, 4 2s are 8, 8 2s are 16 times increases. Okay. By increasing the temperature from 10 degrees Celsius to 50 degrees Celsius, the rate will become 16 times. 16 times faster than the initial. Clear? Next, similar problem. Here for reaction means this is temperature coefficient. Clear? When the temperature is increased from 30 degrees Celsius to 80 degrees Celsius. So here we 10 to 50. Simply here 30 to 80. The rate constant K increased a factor by 32. Means here 16 times, no? Here they gave 32 times. Then what is X? Simply here. So for every 10 degrees rise in temperature, the reaction coefficient may be 2 or 3, no? So X may be 2 or 3 simply. Suppose you can take 2 instead of X. Simply here 30 degrees Celsius, 30 to 40 degrees Celsius, 40 to 50 degrees Celsius, 50 to 60 degrees Celsius, 60 to 70 degrees Celsius, 80 degrees Celsius. Suppose you can take 2 for every 10 degrees rise in temperature, the reaction rate may be doubled. So 2 2s are 4, 2s are 8, 8 2s are what? 16, 16 2s are 32, no? Yes, right. So simply 1, 2, 3, 4, 5. 2 power 5 is equals to 32 times. Simply what is X here? Therefore X is equals to what? 2. Okay. So you have to match. Is this the temperature coefficient? The x value may be, majority of the reactions have 2. So only few reactions 3. So first you have to calculate with 2. If you want to get answer, you can take 3 simply. Okay. So this is what? Temperature coefficient in that x value 2. Clear everybody? 7th problem. The rate of a reaction doubles when its temperature changes from 300 kelvins to 310 kelvins. The activation energy of such reaction will be, what he has given? Simply, what we have to calculate first of all, activation energy we have to calculate. Now, temperature T1 is given as 300 kelvins, T2 is given as 310 kelvins. Okay. Now, simply R is given as 8.314. Okay. Then log 2 value. So, by what is the related formula for this? So, we need to take which formula? Simply for different temperature, different rate constant. Okay. Log to the base 10 of K2 by K1 is equals to activation energy EA by 2.303 R into 1 by T1 minus 1 by T2. This is formula for this problem. Okay. So we need to calculate activation energy. Okay. So then simply here, rate of the reaction doubles when temperature increases from T1 to T2. Rate of reaction doubles nothing but K1 is maybe 1, K2 is double 2. Simply here log to the base 10 of K2 is taken as 2, doubles means K2 is taken as 2, K1 is 1. See here we have to calculate activation energy. Next 2.303, R value is given as 8.314 joules Kelvin inverse mole inverse into 1 by T1 is given as 300 kelvins minus 1 by 310 kelvins. Okay. Simplify this. So log 2 by 1 nothing but log 2, no, log 2 value is given as how much? 0.301. Okay. So then these values are right here 2.303 into 8.314 is equals to activation energy. So 1 by nothing but 310 minus 300, 300 into 310. Okay. By multiplying this, we will get 5.76. So here EA, by simplifying this value, 10 power minus 4. So simply therefore, activation energy EA is equals to, so this is taken in denominator. Okay, I will write here. Activation energy EA is equals to what? 5.76 by 10 power minus 4. 5.76 into 10 power 4 only. So that is what joules Kelvin inverse mole inverse. So this is also written as 57.6 into 10 power 3 joule Kelvin inverse mole inverse. So instead of 10 power 3 we can take kilo joules Kelvin inverse mole inverse. Simply 57.6. Okay. So you can check this value. You can calculate again. So whether it is right or wrong, so comment me in the chat box. Clear? Then go for next. Problem is similar to 7th problem. Okay, here activation energy is given here. EA is given. How much? 58.3. Ratio to rate constant temperature T1 is given as T1 is given as 300 kelvins. Lower temperature is taken as T1. T2 is given as 305 kelvins. So what is the ratio of rate constant? Simply K2 by K1 we have to calculate here. So what is the formula? So you can do it ma. So very simple. I will write formula. Log K2 by K1 EA 2.303 or 1 by T1 minus 1 by T2. Okay. EA is given, R is given, T1 is given, T2 is given. Okay. So by calculating this we will get X suppose. So simply we have to calculate what K2 by K1 no. So this log is taken to here, we will get anti-log of X will get answer here. Okay, answer suppose answer is Y. Okay, so already they gave a hint no, anti-log of value. So simply X approximately 0.1667. So we will get almost similar to this answer. So you can do it and comment the answer, okay, in chat box. Clear? So your next problem. The reaction 2A plus B2 gives rise to 2C is an elementary reaction of a certain quantity of reaction. If the volume of reaction vessel reduced by factor 3, the rate of a reaction increased by factor, how much rate will be increases? First of all, you have to write rate law for this equation. R is equals to K into what is that? Concentration of A power 2, concentration of B2 power what? 1. Okay. So this is also written as simply here R is equals to K into concentration nothing but number of moles of A by volume of A power 2 and number of moles of B2 and volume of B2 power 1. Okay. Now, so this is maybe R1. So this equation taken as 1. Now this is initially, but after volume of the vessel reduced by 3 times. Reduced means decreased. Simply here. So here you can take R2, second condition. K into concentration, nothing but number of moles of A by volume of A. This volume decreased by 3 times. Okay. Power 2. Next. NB2 by VB2, this B2 volume also decreased by 3 times. Okay. So this is equation 2. Okay. Now this is written as K into what happened? NA by VA power 2 3 power 2. So this 3 will become numerator. So this is similarly what? 1 by 2 no. So this 2 will become here. Okay, clear? Next. NB2 by VB2 same 3 power 1. Okay, so simply this is taken as second equation. Okay, so by dividing equation 2 by 1, how to get? Simply here R2 by R1, that is equals to K into NA by VA power 2 3 square NB2 VB2 into 3 by K NAVA NBVB. Okay. Now KK mutually cancel. NA Na by Va power 2, Na by Va power 2, Nb Vb, Nb Vb. So what is remaining? 3 square into 3. How many times? 27 times increases. So volume decreased by 3 times. Here rate increased by 27 times. Clear? So suppose given as reduced volume, no? So increased volume is given. Suppose for example, volume increased by 3 times. What happens? Rate of the reaction. Simply here, then you can take here volume increase 3 times. No, here we can take A is equals to R2 is taken as Na Va into 3 here. Okay. Next Nb Vb into 3 here. So simply by calculating we will get finally what? 1 by 3 whole square into 1 by 3. So that is simply 1 by 27. So means rate of the reaction decreased by 27 times. So what you get from this here? Simply rate of the reaction, nothing but concentration, nothing but number of moles per volume, no? So simply here rate is inversely proportional to volume. So if volume decreases, rate increases. Volume increases, rate decreases. Okay. So you have to practice similar problems. Okay, ma. Next, I will give you one problem for homework. Okay, simple problem. See you. The chemical reaction A plus B gives rise to C. If the concentration of both A and B doubled, so what is the rate will be? Okay, you can do it, ma. So write the comments. I will give you a hint. So write rate law for this. R is equals to K into concentration of A, concentration of B. Per 1, no. So this is R1. Both concentrations are doubled. Then what happened? Okay, you can do it and put the answer in comment box. Okay, that's all for this video. So in the next video we will do another problems on order of the reaction and half-life. Okay, so they are very important, so don't miss that video. Okay, ma. So thank you for watching this video. So please like, share, subscribe my channel to get more videos. Okay, thank you, thanks a lot.